Hello. Hello.
Good morning, madam.
Yes. Good morning. So now we'll start. Just wait for 2-3 minutes. I have to collect the material. Then I will continue. Wait for 2-3 minutes. Okay. So today I'll continue the discriminant analysis. So I think already we have discussed the fundamental of discriminant analysis. So today I will cover you. I will cover that discriminant analysis and 2A ANOVA. And I will try and another one, that is your factor analysis also, or multivariate regression analysis. So one thing you have to remember. So the discriminant analysis and multivariate regression analysis, all the multivariate techniques, it is better to use the software SPSS. So through SPSS, I will do that one. The steps also I will make you understand, so that you can do, install the SPSS package in your laptop. After that, you can do that one. Okay. And in the exam, if it will come, what is the short note type factor analysis, discriminant analysis, that you can write. You can follow the steps and why you are using that factor analysis or discriminant analysis or multivariate. You can get the theoretical notes means any multivariate analysis book you follow, you'll get that one. Means what are the conditions? If you need afterwards, I can supply you the theoretical notes related to that. But how to do the multivariate analysis means it is used for practical purpose, means application purpose. So in your research project work, any means dissertation or any type of short case study, in that case you can use these multivariate analysis for that case. Okay, so here now I'll make you understand today that discriminant analysis, and also I have told that it is not in your syllabus, that logistic regression analysis, but it is coming under multivariate also. Okay, logistic regression analysis, it is also very much useful nowadays. That also I'll make you understand through one case study I have done, and that particular paper, it is published in one proceedings of the conference, international conference. That also I'll show you. First I'll make you understand about that discriminant analysis. Okay, so let us start. I will share you the screen. So this particular material also today I'll share afterwards. I think all of you have got the rest of the material. So discriminant analysis already I have told you have to use for prediction and classification purpose. So first you have to classify, then you have to go for predict. Okay, so suppose the equation it is given by y equal to a plus k1 x1 plus k2 x2, and where x1 and x2 are two independent variables. X1 and x2 are two independent variables, and k1 and k2a are constants. Okay, and y is the dependent variable or categorical variable, non-metric variable. Okay, categorical variable or non-metric. Non-metric already you know what is the meaning. That is also coming under categorical variable. It is also coming under non-metric variable. So discriminant analysis is somewhat similar to regression analysis. The dependent analysis, the dependent variable is non-metric, but in case of regression analysis, it is metric. So what is the difference between discriminant analysis and regression analysis? Discriminant analysis, the dependent variable is a non-metric or categorical variable. Whereas in case of regression analysis, dependent, independent, all the variables should be metric. You have to remember that one. Okay. In case of selection and classification, prediction, selection, classification, and prediction, we have to use discriminant analysis. So already I have told when you use that discriminant analysis for selection, classification, and prediction, all these you can do through discriminant analysis, but you have to remember some conditions. Okay, through that only you can use that discriminant analysis, otherwise not. The objective is to choose. What is your objective? So for any type of analysis, there must be objective. So the objective is to choose K1 and K2, which maximize the separation between the two groups of variable. So here generally discriminant you have to use for the two variable. Okay, two classification, 2A classification, either boy or girl, either educated or uneducated, either means this type of category you can do. Already it is told that you have to the dependent variable means that y is the dependent variable, that must be non-metric or categorical. So categorical means either or. Okay. So means there are two classification. Okay. So in such a way that you have to separate in such a way that maximize the separation. So you have to choose what x1 and x2 must be given to you, but you have to choose k1 and k2 in such a way that which maximize the separation between the two groups of the variable. Means boy, girl, girl. Means there should be there should not be any confusion. And how to separate that one? by choosing K1 and K2. That means we have to find out K1 and K2. X1 and X2 must be given to you. Only you have to find out K1 and K2 so that you can separate the gender, whether the particular classification it is, whether that particular classification it is related to boy or it is related to girl. Just I am giving the example. Okay. So now we'll come to the point, the next page, that is example of discriminant analysis. So already we have discussed when you use the discriminant analysis, that is the selection process for a job, whether you'll get the job or not, means selected or not. Means if these are the criteria, then these are the qualification criteria, eligibility criteria, then whether that particular student he will get the job or not after completing MBA or whatever, okay, or BTech, like that. Then admission process of an educational program, what should be the educational process, whether you got the seat in that particular college or university or not. If this is the score, these are the criteria for means career mark, and this is the entrance mark. Then whether he or she will get the seat in that particular university or college or not, that is admission process. Selection of salespeople, supplier, investor, selection process, potential buyers or non-buyers. So in case of marketing research, or the manufacturer wants to know whether the particular customers, whoever it is coming, whoever he or she is coming, whether he or she is the potential buyer or not. If these are the criteria, some criteria must be given, some variables must be known. Okay, then only you can decide whether he is a potential buyer or non-buyer, potential investor or non-investor, like that way. Two-way classification you can do for you here. So two classification. So a particular consumer is a brand loyal or brand switcher. That means the customer particular, whoever he is coming to your shop, whether he is a brand loyal, the same brand he will purchase, or another month he will brand switcher. He is the brand switcher, he or she is the brand switcher. That also you can classify. Then the steps it is coming. So steps it is coming means in SPSS how to go for analyze that discriminant analysis type method. Okay, statistical tool. So what are the steps? Here I have written the step. So those who have the laptop, please you download, or please you download the package and you install in your system, so that you take your own example, this particular example, whatever we are discussing now, just you can give the input and you'll get the result or not, that you have to test. So these are the steps. First you have to go for input, then classify, mean or average. So this is actually theoretical manual calculation. Another one, SPSS calculation steps, I will make you understand afterwards. So this one is your input, means the data. Then you have to go for classify. First you have to find out the mean or average. Then you have to calculate the grand mean. Then you have to calculate sum of square and sum of product. Define the linear equation. You have to define the linear equation. Solve the normal equation. There are two normal equations you will get. So that you have to solve that one. Write the final equation. Then evaluate the discriminant ratio. That is the most important one. That is your K. Because you have to find out K. Through that K only you can go for classification. That's why the most important thing is that how to calculate K. K is known as the discriminant ratio. That is your constant. You have to calculate it. After that only you can discriminate whatever you want to discriminate. Okay. Discriminant means you have to classify whether he is a boy or girl, whether you get the job or not, whether he'll get the seat in the university or college or not, everything, whether he is a buyer or non-buyer, whether he is a brand loyal or brand switcher, everything you can do for any type of example. Then evaluate the discriminant score table, then formulate the hypothesis, test, interpretation and conclusion. So like this way, these are some steps you have to follow to solve the problems related to discriminant analysis, which is manually, means by using calculator. Manual means using calculator. Then after that I'll make you understand the same type problem, how to use the SPSS package and what are the steps afterwards. So first manually you will solve one question. So please you listen carefully and see this material. The question is that the director of a management school wants to use discriminant analysis concerning the effect of two factors, namely yearly spending and infrastructure of a school. So X1 and X2, here, what is this? So that you have to choose. What you have to choose? That just first I'll read this question. You read this question carefully, then what to do, I'll make you understand. So two factors means two independent variables. One is your yearly spending in lakh on infrastructure of the school. For the school, what is the yearly spending in lakhs for the infrastructure? Another one, yearly spending on interface in events of the school. So whatever the event, annual function, then any fest, any exhibition, science exhibition, like that, whatever the interface event, what is the yearly spending? And regarding that infrastructure, what is the yearly spending of a particular school, any particular school? Then you have to go for grading the school. Whether the grading the school means then the inspection team, they are coming after checking the yearly spending on infrastructure and yearly spending on interface event. They can grade the school. Who will grade the school? The inspection team. Okay, they will classify. He has collected. Similarly, how many collected the collection of data? Past 12 years, means 12 number of data it is. Yearly data it is here, means 12 data, 12 number of data points submitted to the inspection team. So 12-year database they have submitted to the inspection team. In that case, based on the data, the committee has awarded one of the grade for each year as soon in the same table. So how to do? Okay. So design the discriminant function. Now we have to design the discriminant function. Since there are two independent variable, it is two independent variable, that is your yearly spending on infrastructure, yearly spending on interface events. Okay. So Y is your dependent variable, means that we have to go for grading the school. Which grade we have to give. So compute discriminant ratio. So what is the objective? Already I told you have to compute the discriminant ratio. That is the most important one. Okay. Variable which is most important. So validate the discriminant function using the given function using the given data by forming the groups based on the critical discriminant score. So this is your the database. Okay. Actually, the question. This is the database. You can see the question that year means I have already told 12-year data, 1, 2, 3, 4 up to 12. Grade already it is mentioned. I have already told some data must be given to you. So that only you have to go for prediction and classification. So if infrastructure for school 1, it is 3 lakh for year, 3 lakh, all are in lakh. And interface event it is 4 lakh. Then grade it is previously the grade it is they have got B grade. Similarly, another school they have spent 4 lakh for infrastructure and 5 lakh for interface event. They have also got the grade that is your B previous years. These are the data for previous years. Now after giving the previous years data, they have means how to predict further. Further means whatever if you, suppose I am the leader of the inspection team, director of the inspection team. I have to collect the information. If these are the data for 12 years, then now whenever I visit to any school, that I am asking that what is your infrastructure means yearly infrastructure spending and interface event spending for the means per year, then I can grade easily. Okay. If this much data, historical data if you have, then you have to frame one model, then you fit that particular X1 and X2 data that directly whatever the score it will come, then you can identify which grade you will give, whether it is A or whether it is B, that you can put. Okay, that you can classify and also predict. And also predict. One type of classify means you are classifying whether it is A group or B group, it is coming under that one. That is your classification. the first prediction, then classification. First your prediction means what it is coming, whether it is coming A or B. Then you can classify, means which group it is coming. That is your classification. Now you are getting my point or not? All of you are getting the meaning of this discriminant analysis. When you will use this particular analysis, it is very much useful. Okay? All of you are getting?
Yes, ma'am.
So here, this is your database. So when the A credit is coming, if the infrastructure spending it is 10 lakh and interface event it is 7 lakh. Okay, so like this, these are your data points. Then what to do? This is the objective. Test whether the group means are equal to importance at 5% level of significance. We have to go for testing. Okay, so we have to go for validation. We have to calculate D ratio, means discriminant ratio K, and which variable discriminant ratio, and through that discriminant ratio you can identify that which variable is important, means whether x1 variable is important for classification or x2 variable is important for classification. That also you can identify. So this is very, very essential for any type of classification purpose, binary classification usually. And one thing you have to remember, that y must be categorical variable. Here this is your y. Grade means what? Y. So y is your categorical variable, either A or B we are writing. That is your categorical variable. So this infrastructure and infrastructure spending, and these two are what? Numerical variable or metric variable. So now it is coming the solution. The combination of the hypothesis, example, first you have to write the null hypothesis. The group means are equal importance. Equal importance. Your alternative hypothesis, you have to write the group means are not equal importance. So this is always same for any type of problem related to discriminant analysis, that you have to write the two groups are equal important. You have to go for assumption. Okay. Then design the discriminant function. This is the discriminant function, y equal to ax1 plus bx2. So what is the step 1? Input the data and what? Input the data. Already I have written that step 1. What is step 1 and 2? Just you have to go for step 1 and 2. Input and classify. Okay. So now you have to go for solution and we have to write the input data. Data means and you have to go for classification. So classification means, so here B written means below grade, A means A above grade. Okay. So here grade, here it is written B means below, A means above. So here it is below rating. Okay. And A means above. Whatever they had thought that above it means par with that whatever they have fixed, and it is below. So like that way you have to first write the data points, 12 data points, whatever it is written in the question. Then we have to go for that which one is your means below group, which one is your above group. Clearly it is written here. Then go for step 3, the mean of x1 as well as x2 in each group. Now you have to calculate mean of x1 and x2. That here it is we have got mean of x1 and x2. Okay, so the total it is 42 divided by 7, that is your mean. Mean is your 6 for x1 and mean of x2 it is your 5, that you have to calculate. Then here it is actually group wise you have to do. Group wise means this is your group 1 and group 2. So group 1 means I have taken here that below group, and group 2 that is your above group. So out of these 12 data, first you have to categorize it, means classify it. That is your first you have to write in a tabular form, step 1. In step 2 you have to separate it, means classify it in below one table and above another one table. Third one you have to calculate the mean of each group. So group 1 that is your below group, and group 2 that is your above group, you have to calculate the mean. Mean already I have shown you, mean of x1 and mean of x2 for below group. Similarly, mean of x1 and x2 for above group. So this one I think you can understand. Then grand mean you have to calculate. So grand mean also in the step 3, I think step 4. Step 4 it is coming, the calculating necessary results to solve the normal. Okay, step 4 is different one. Step 3 grand mean also you have to calculate. First, you have to calculate mean of each group. Then you have to calculate the grand mean in step 3. So step 3, you have to calculate grand mean. Formula is that for each x11, for each group, you have to calculate grand mean, means that x1 group and x2 group, that summation whatever you have calculated divided by total number of data. Sorry, first for that below group, and just I will show you 42 and 60 where it is coming, just to check. So 42 and 60. Okay, so below group and above group for x1, you have to calculate the grand mean, means below group the totality is 42. Similarly, above group the total is 60. So for x1 you have to calculate a grand mean, that is your 42 plus 60 divided by total. Total is 12 here. So divided by total 12. So you are getting 8.5. So grand mean for x1 group, grand mean for x2 group. Similarly, x2 group, what it is the total for below and above? For below it is 35. For above it is 30. So 35 plus 30 divided by 12. So you are getting 5.4166. So like that way you are getting the grand mean for x1 group and x2 group. And capital N is your N1 plus N2. N1 is your group 1 total and N2 is your group 2 total. So like this way, I think all of you are getting the meaning of step 3, how to do the step 3. Yes or no? So up to step 3 you are getting? Hello? Hello? So up to step 3 all of you are getting or not?
Yes, ma'am.
Yes, ma'am. Yes, ma'am. Getting.
Very good. So next, I have written everything. So you can understand directly, you solve this problem, you can understand easily. So it is not so difficult. Then next we will come to step 4, calculation of necessary results to solve the normal equations. So step by step it is written clearly. You just today only you have to solve this problem so that you can understand. With the long question it must come. Okay. So to solve the normal equations are summarized in table 3. Now you have to go for what? Calculation of normal equation. So how to do that one? Just will come to the next. Okay, table 3. So to solve the normal equations, you have to calculate this table. So what you have to do? So you know that group 1 means below 1 to 3, 1 to 4, 5, 7, 9, 10. These are the years, and below group. So for that case, x1 and x2 already you have already written that one, and you have to calculate the extra, that is your x1 square, x2 square, and x1, x2. Okay. Then you have to calculate the total of all these, and similarly table 4 also for group 2 you have to calculate all these, that x1 square, x2 square, x1, x2, and these are for above group, that is for below group, and these are for above group, and number of item, that is for group 1 it is 7, it is 5. Then you have to go for grand mean. Grand mean already you know that 8.5 and 5.4166 already you have calculated. Then now you have to go for table 4, refined forms of sum of square. Refined forms of sum of square. Okay. Hello. कौन है ना ना मु तो बे ऑनलाइन रे क्लास नउची तू कोन आसीबो कि डिपार्टमेंट ना मोर जिबार नै जदी दरकार पड़े साने फोन करियो मु जिबी मु आज से प्रोजेक्ट ए क्लास टा नै सरला परे प्रपोजल टा को रेडी करबे बे हला हमरो टाइम का हम केतले करी बसी की धीरे धीरे बसी करूची कोन मु अब क्लास टा नै जाय ऑनलाइन ने क्लास नउची नै सारे तापर करी तो जदी दरकार आसी न नै जिबो हम गुरु अच्छा भी हला हम क्लास टा नउची तो कंटिन्यू अछि हला hello. Then now we'll do this calculation we have to do, that is your sum of square for below and above and total. So what is the sum of square? The formula is x1 square minus nx bar square. Okay. So what is your summation x1 square? Summation x1 square already you have got for below group 280. Okay. And what is your x1 bar? That is your 6. What is your x2 bar? That is your 5. Here I have written x1 bar 6 and x2 bar 5. Mean of below mane x1 bar and x2 bar. Okay. So that you have to put here. X1 bar, first summation x1 square. So this is your means calculation that you can do by yourself. N x1 bar square, n means number of data, 7 into x1 bar means x1 bar already have got what? X1 bar, that is your 6. So by putting that one and calculating, you'll get 28. 28 you have got. Similarly for above means for this above group, this one, what is your summation x1 square? 730, and x1 bar, that is your 12. So like that way you can use this one and you'll get 10. Sorry, here also 10. Similarly for x2 you have to calculate. Then these are the total. 28 plus 10, that is your total, and these are total. Similarly, product summation x1 x2, summation x1 x2 also we have got here in this table. That is your 217 for this case. Below case, for above case it is 364. By using that one you can do this calculation. And here it is for below group and here it is for above group, that is 7 and 4. The total it is 11. Okay, so like this way we have to go for step 4. Then next it is coming, let the linear components of the discriminant function. So what is the discriminant function? Already you have written y equal to a x1 plus b x2. Okay, then you have to form step 6, that is your normal equation. Normal equation we have to frame. So how to go for normal equation? So this is the formula: a summation x1 minus x1 bar whole square plus b summation x1 bar x2 minus x2 bar, then x1 bar x1 bar g2 minus x1 bar g1. Similarly, second equation like this. So already the data we have got 38, 11, 18, and this is 12 minus 6, 6 minus 5. Already have got the grand mean. Already have got, okay, grand mean. So that value just you put 38 and 11. Where you will get all these? The summation whole square already have got in the table. Which table? This table. 38, 11, 18 already have got. This value you put here so that you will get two normal equation. Two linear equation or normal equation you can say. The 38a plus 11b, where a and b are two constants. Okay, that is your 6. Similarly, 11a plus 18b is equal to 1. So now you can solve this equation, these two equation, and you will get a and b value. Simultaneous equation. I think all of you have known how to go for simultaneous equation. You solve it, you will get a and b. These two are your constants to frame the discriminant function, that is your y is equal to ax1 plus bx2. So this a and b just you put here, you'll get the equation. So after putting x1 and x2, whatever, suppose it is 3 lakh for infrastructure and 5 lakh for interface event, you just put here 3 and here it is 5, you'll get one numerical figure. Then what you'll do that numerical figure, that is your y. Okay, so through that only you have to go for grading. So how to get the grade of the particular which grade you will give, that is your objective. So now computation of the discriminant ratio, that is your k, and identification of the variable which is more important. Now this is the most important point, that we have to calculate the k and identification which variable is the most important one. So here that y bar already y we have already got the 0.17229, x1 and 0.4973. What we have got here? This value we have got. This one you can write in the form of bar, because regression equation passing through x1 and x2 is also remaining same with. There is one property of regression analysis that one suggestion I am giving, that those who are present today, please you go through that correlation and regression basics, because I think it must be there in your second semester, correlation and regression. Otherwise you cannot understand the multivariate regression, because bivariate first you understand, then only you can go for multivariate. This is also one type of regression. So one of the most important property in regression analysis is that regression equation passing through, because regression equation, that is just here it is linear, means straight line. Regression equation passing through x1 and x2 is also remaining same with the x1 bar and x2 bar. Okay, that means it is why it is like that, because regression analysis is the average relationship. It indicates the average relationship between the two variables. It indicates, okay, it studies the average relationship between two variables. That means it is passing through x bar and y bar. It also remaining same with x bar. Sorry, it is passing through x and y is also remaining same with x bar and y bar, means it is also remaining same with the average. That's why instead of y, x1 and x2, you can write y bar, x1 bar and x2 bar. That's why I have written y bar below is equal to this much. Okay. So if we put below here, then x1 bar value is what? 6. X2 bar is equal to 5, that you put it and you'll get y bar below value. Y bar below value you have got 0.78509. Similarly, y bar above we have to calculate. Y bar above, x1 bar, what is x1 bar for above and what is x2 bar for above, already you know. Before you calculated, just you put here. So after putting that one, so what is x1 bar and x2 bar for above? Just you have to check here. For above, the x1 bar and x2 bar will be equal to that 60 by what? 5, that is 12. Similarly, 30 by 5, 30 by 5, 6. So 12 and 6. So here you have to put 12 and 6. You have written no, 12 and 6. Okay. So for above the mean, it is 12 and 6. Now you put here so that you will get y bar above. Y bar above. So instead of x1 bar, you can put 12, and instead of x2 bar, you can put what? 6. So that you will get 1.7691, and it will be y bar above. So y bar above we have got, y bar below you have got. Then you can find out the grand mean. So grand mean is equal to, you have to write x1 bar and x2 bar. So grand mean value also you know. X1 bar, what is your grand mean? For x2 bar, what is your grand mean? That you put, you will get that this one. So grand mean of x1 bar and x2 bar you have got here. .5 and 5.4166. That value you have to put here, you will get grand mean. Okay. So you will get y bar grand mean, y bar above, and y bar below. Next we will come to discriminant score. So discriminant score. So here this is your general equation, y equal to whatever discriminant function we have got. Then below G1 and that below G1 and that we have to calculate here. This one data set 1, 2, 3, 4, 5, whatever the data set for below, and this is your year. Then discriminant score. Okay, for year 1 you have to calculate discriminant score. Then you have to calculate this one. Then similarly for year 2, like that, your discriminant score. So how to calculate this Sij? Sij you can calculate. For year 1 you have to put the value here, means in y, what is your x1 and x2, given x1, x2, and you get here Sij. For each and every year you have the data of x1, x2, that you put in the above equation, you will get all these. Okay. Similarly for this case also the same thing you have to do for above. So you have to put the value of year 3, what is your x1, x2, you put in that equation, you will get everything. So like that way you have to calculate and the total and mean, so that it will be discriminant score. Discriminant score, it will be 14 point. The grand mean discriminant score, you have got 14.34113, and grand mean discriminant, it will be 1.19, this one. Okay. So validity between the group and validity between the group, validity, not validity, variability between the group and variability within the group, that you have to calculate by using this formula. Okay. So this portion, it is necessary for calculating the discriminant ratio. Okay, discriminant ratio, the formula is variability between the group, variability within the group. Then whatever you are getting, that is the discriminant ratio. So this is very important to calculate, because afterwards you can identify which variable is most important through this discriminant ratio. Okay. So K we are getting 2.87. So this is the maximum possible ratio between the variability between the groups and the variability within the group. Next, Next, we will calculate. This means that the variable x2 is suppressed in discriminant function. Then that revised value of the discriminant function. Then the revised value of the discriminant ratio will be less than the previous value. In the discriminant function, we have got that 0.17 this one and 0.04973 x2. The coefficient of x2 is negative sign, which indicates that the variable x1 spending more than the variable x2. Okay, so variable x1 is spending more on variable more. That means it is more important than the variable x2, since it is coming negative and x1 it is coming positive. That's why we are saying that negative means negative of 0.049, and here it is coming 0.17. That means variable x1 is more important to discriminate that whether it is coming under below group or above group. Okay, so like this way, this is the testing procedure. I think it is not necessary. So this is all about related to that that discriminant analysis. So now I will show you how to do this one by using SPSS, so that you can understand actually the meaning of this discriminant analysis. Because whatever the problem, it is very difficult, since it is 12 number of data points you can do by using calculator, but it takes 1 hour, I think. So it is very difficult to do. The theory means theoretical short notes you can write by yourself, and what is the practical applications, everything you can write, and related to that discriminant function and all the means constant, what is the meaning, notations you can explain, and up to these steps, grand mean steps, everything you can write by yourself. But if it is suppose the data, suppose you are doing any project or research, it is not like that only the 12-year data, it may be 50-year data, 100-year data. In that case, it is not possible to solve it manually or by using calculator. In that case, it is better to go for software, using the software, or yes, software package. SPSS, through SPSS you can do directly, within 1 minute you'll get the results. Okay, but how to do, now I'll show you. Just wait for 1-2 minutes, I'll show you. Oh. Just wait for 2-3 minutes. I'll show you. I'm trying to get that material. So I think it is visible now.
Yes,
Material
madam.
11 case on discriminant analysis. All of you are getting?
Yes, ma'am.
Okay. A retail outlet. This is the applications related to discriminant analysis. Directly, I will make you understand through this material. The retail outlet wants to know the consumer behavioral pattern of the purchase of products in two categories, national brand or local brand. That is the classification. So in that problem, it is below and above group. Okay. Here it is national or in local, which would help it to place orders depending upon the demand and requirements of the customer. This retail outlet in another location to arrive at a decision about the customers visiting at their end. Okay, so this retail outlet wants to use discriminant analysis to screen the responsiveness of the customers towards the national brand or local brand categories and find out the following. So what you have to find out, the percentage of the customers that it is able to classify correctly, means classification, whether the customer is coming under choosing national brand or choosing local brand. The two different brands it is available in the outlet. According to the customer demand, whether he demands national brand or he choose the national brand product or local brand product, that you have to find out. So so how to classify that one? What are the independent variables? That we'll discuss. So here national brand and local brand, these are categorical variable. That means we can apply. We have to classify in through categorical variable. We can classify by using discriminant analysis, statistical significance of the discriminant function, then which variable are relatively better in discriminating. That already I have told. Suppose there are two variables, which variable is most important than another one, that also you can find out, and you have to classify. Okay, first you have to predict, then you have to classify that whether the new customer is coming under choosing national brand or local brand. What are the different criteria to choose that one? That here serial number, what is the sample size I have taken? 20 sample size. These are the brand. Brand means 1 stands for national, 2 stands for local. So always you have to remember that SPSS package cannot understand the theoretical or theoretical information. Whatever national, local, it cannot understand. You have to give the code. You have to give the code for national, it is 1. It is not necessary you have to write national for 1. According to you, national you can put 2 or local you can put 1 according to you. So here I have written 1 for national, 2 for local. Then what are the criteria to choose that 1 or 2? The criteria, it is given 20 number of sample points. Already you have taken that one. The annual income you have taken and household size. So first you have to ask that what is your annual income? Any customer, he or she will come. You have to give one. You have to give one card. There must be written that fill in the blanks. What is the annual income and what is the household size? According to that, you can classify that particular customer. He will opt for whether national brand or local brand. You can predict that one. So that how to predict that one? From model only. So you have to frame the model and you can discriminate whether he is the national brand customer or he is a local brand customer. Okay. So these are some data points. It is given to you. Without data points, you cannot frame the model. So here it is 20. It may be 200 also, like that. So in that case, it is very difficult to go for manual calculation. It is best to use what? That is your SPSS package. So this is the steps. Steps I will make you understand that how to do that one. So after using the SPSS package, we have got classification results. That discriminant canonical discriminant function coefficient, and this is your weak lambda and standardized canonical form and group centroid. So like this way you have got the results. So if these are the results, then how to write the conclusion? So conclusion how to write, I'll show you. So the results I think you can see here. Just I'll minimize and another material I'll show you. So I think all of you have got the question, the meaning of the question. All of you have got the meaning of the question. All of you have got the meaning of the question or not? discriminant analysis?
Yes, ma'am.
Okay, so now I'll show you, after using SPSS, we have got this much results. So these are the result tables. You always you have to remember that any software package you use, only you will get the result, nothing else. You have to interpret that result. Means you have to interpret each and every table. Only in tabular form you get the results. But how to use that SPSS package and what are the steps and how to write the interpretation of all these tables. Now I will make you understand. So here I'll minimize, or I'll again I have to show this table. So here I'll stop share, or what I'll do. Simultaneously I cannot show two. Simultaneously I cannot share two. Suppose this one I'll minimize, another one I'll start. Is it possible?
Yes.
So this one I will minimize. Okay. This one I minimize, and another how will minimize? I cannot minimize this one. Stop share I have to do, I think. What? Okay, anyway, I'll stop share and I'll show you another material. Those who are talking, please mute your. Okay. Now you please see this material. So please you mute those who are talking. Please you mute your mic, those who are talking. Hello.
Sagarika madam, please mute yourself.
So now this is the material for results. Okay. So actually this one it is coming like this way. एटा तो मु सेमती एमती करि पारुनी केमती सेटा को मूव करी भी जानि पारुनी एक्चुअली जे फोटो उठीची सेमती फोटो उठी दीची सो एनीवे द
मैम अपन सेठी व्यू जाई कि
ऊपर ऊपर मैडम रोटेट ऑप्शन अछि
व्यू
ऊपर रोटेट ऑप्शन अछि राइट साइड
रोटेट अछि
तार एंड रे राइट एंड रे
एटा
व्यू व्यू ऊपर फाइल एडिट
रोटेट ना
व्यू करते नहीं रे मोर भीतर अछि की ना ना एठी तो मत कांदे ओहो व्यू व्यू बुझिली हां rotate view. Okay, clockwise. Okay, so here that particular question, this is the this is the interpretation how to write. So brand and variable. Brand is your group 1 and group 2. Group 1 that is your national and group 2 that is your local. And variable you have taken annual income and household size. Okay. So what is the objective? Objective for that particular question, how to write that one. The objective is to know that consumer behavioral pattern for the purchase of the two types of product, either it is category 1 and category 2, that is a national brand or local brand respectively, depending upon the two independent variables, that is your annual income and household size. Okay. Now how to do? This is the discriminant function y equal to, here I have taken b1 x1 and b2 x2, or you can write a x1 or b x2, whatever. Okay, according to you, b1 b2 you have to find out. That is your standardized discriminant function, and this is your unstandardized discriminant function if you put a. Okay, so the case of discriminant analysis, that two types of discriminant functions, standardized discriminant and unstandardized. Standardized means there should not be any constant, that is your intercept variable A, but unstandardized there should be A. So next, okay, next, what to do? The table 1, from table 1, it can be, table 1 means already I have shown you the table. So this one again I have to minimize, then I have to show this table. Table 1 already have got that SPSS results. It can be concluded that the discriminant function is obtained for the, first I'll read this particular interpretation, then we'll go to the table again. Okay, 85% of the table, 20 objects correctly, classify correctly. Out of 20 objects, 85% classify correctly. It indicates 11 cases predicted to be group 1 and 9 number of data points were observed to be group 2. So in that table, whatever the result we have got out of 20, which one coming under what group? Means 11 cases coming under group 1 and 9 cases coming under group 2. Group 1 is your national brand and group 2, that is your local brand. Similarly, for the table 2, unstandardized discriminant function, unstandardized means y equal to a plus b1 x1 and b2 x2, where a, b1, b2 are constants and x1 and x2 are two independent variables, like that. So from this table we conclude that, so already the value we have got from the table, directly we put in the equation form. Since a is not there, that means it is unstandardized. So always you have to write unstandardized discriminant function. Unstandardized means that is your a is equal to minus 4.545 and b1 is equal to 0.335. Already in that table it must be there, just you have to write in the equation form. Okay, and b2 is equal to minus 0.313. So from this discriminant model, it can be concluded that out of these two independent variables, annual income a better predictor than or a best predictor. Annual income is the first one. Second one, that is your household size. Since annual income it is coming positive, that's why it is written that annual income is the better predictor than household size, because household size it is coming negative coefficient. That's why in case of choosing the best predictor, we have to take absolute value of the coefficient of the independent variable. Always you have to take absolute value. Actually, why it is better? 0.335, and if you take the absolute value minus 0.313, then 0.335 more than 0.313. You don't take minus. If it is also positive, then which one is the better? Always you have to take the absolute value for comparison cases. That means 0.335, that is your positive value. Another value it is coming negative, you have to take positive. But you compare these two value, 0.335 and 0.313. 0.335 is more than 0.313. That's why that annual income is the best predictor. Okay. Then in case of discriminant analysis, we have to use Wilkes lambda. Wilkes lambda table also you have got there. So from that result, what you have to write the interpretation? For testing the significance of Wilkes lambda range lying between 0 to 1. Always you have to remember Wilkes lambda range must be lying between 0 to 1 with a lower value of Wilkes lambda indicating better discriminant power of the model. In our case, jette lower haba sete bhalo, 0.5 ru below hele bhalo. So in case of our case, 0.473, which is reasonably good, being close to 0 to 0. Okay, that means if it is close to 1, the model is best one. If it is close to 0, it will be less powerful. Okay, so since it is lying between 0 to 0.5, that is 0.473. Okay, that means the model is means the discriminating power of the model, it is reasonably good. You cannot say very good or excellent. You can say that it is reasonably good from the Wilkes lambda value. The next table, that is your table 4. All the interpretation it is related to table 1, 2, 3, 4. So that I'll share you the material. You can understand everything by using the standardized discriminant. That is your unstandardized model. Previously you have written table 2. Then table 4, it is standardized discriminant model. Means there is not available any point of y-intercept, that is your A, only B1 and B2. So B1 is your 0.722, B2 is your 0.490. So from this, you can say that from the table, we conclude that annual income is the best predictor. Here also you are getting annual income is the best predictor because 0.4722 is more than 0.490 because you don't take minus sign, only you have to take absolute figure. The next table 5. Next table 5, for choosing the group of national brand or local brand, you have to go for the scale ranging from -1 to plus 1.003. Minus 1.001, table 5, you'll get one value that minus 1.001 and 1.003 or whatever. You have to discriminate between these two with 1. Okay, if any value it is coming, the value of y it is coming more than 1, then it is we choose more than, if it is more than 1, okay, if it is more than 1, then it is a local brand. If it is less than 1, then it will be national brand. Okay, -1 to 1, then if it is lying between, what it is lying between? Y value. If y value, it is lying between or discriminant score, you can say discriminant score value that is lying between -1 to 1, then it is known as, that means that particular customer will choose national brand. If the value discriminant score is lying between 1 to 1.001, then you'll say that he will choose local brand. So this is the steps you have to remember. Then we'll come to that discriminant analysis. What are the steps, how to do through SPSS package? These are the steps. Drag all these, and first you have to go for analyze, then you have to go for classify. Means SPSS package steps: first analyze, then classify, then discriminant, then you'll come to group variable, grouping variable, then you'll come to define the range, then you have to go for drag, then you have to go for the dragging the independent variable, then statistics. Under statistics, you have to use unstandardized, then continue, then you'll go for classify, then you'll go for summarize the table, then you'll go for continue. Last, you have to go for OK. So that the final results, whatever you have got, SPSS results you'll get, and you can write the interpretation. So like this way, I think all of you have got a little bit idea related to discriminant analysis. If anything, it will come related to long question or this SPSS package also practical application you can do by yourself. So today only I'll share all these materials to you so that you can practice yourself by installing the SPSS package. So I think I'll stop here because it is already 9. Okay. Hello. Hello. Hello.
Yes, ma'am. Okay, ma'am.
Yes, ma'am.
Okay, so you have to practice yourself because it is little bit difficult. Why? Because this is the most important multivariate analysis. It is not bivariate or univariate, and you have to. It is better to use SPSS package. Okay, so I think I leave now. Stop share, and I today only I'll share it. Okay, thank you.